Hello everybody, welcome into another lesson. So today we're going to talk about multiplying algebraic fractions. Basically, you're kind of going to do them the same way we've been multiplying fractions since basic math and pre-algebra, only you got variables involved. So first, what I would do, look at you have 6 over x squared times x cubed over 3. Well, 3 is a factor of 6. You could divide both of those by 3. If you divide 3 by 3, you get 1. Divide 6 by 3, you get 2. And then between x squared and x to the third, there's a common x squared. Divide x squared by x squared, you get 1. Divide x to the third by x squared, you get x to the first. So what you're really left with is 2 over 1 times x over 1, or just simply 2x. This simplifies down to 2x. And I do got more examples here. Alright, let's see. We got 5y over 2 times 4 over 15y. Alright, so we got 5y over 2 times 4 over 15y. Well, 2 is a factor of 4, so if we divide 2 by 2, we get 1. We divide 4 by 2, we get 2. Now, 5y is a factor of 15y, so if we divide 5y by 5y, you just get 1. Divide 15y by 5y, you get 3. So what you're left with now is 1 over 1 times 2 over 3, which would just simply yield to 2/3. That would be how you would simplify this. You would just get 2/3. Alright, here's a fun one. We have a over b times b over c times c over d. Alright, a over b times b over c times c over d. Well, definitely the b's are going to cancel out. And then so will your c's. So what you'll be left with is a over 1 times 1 over 1 times 1 over d. And if you go ahead and multiply this together, you would get a over d. That would be the simplification of this, would just simply be a over d. Alright, let's see. We got 4 over x squared times 7x over 8. So we have 4 over x squared times 7x over 8. Well, between the 4 and 8, 4 is the greatest common factor of both of those. So if you divide 4 by 4, you get 1. Divide 8 by 4, you get 2. Now, between the x squared, then you have 7x, there's a common factor of x. If you divide 7x by x, you just get 7. You divide x squared by x, you get x. So what you're going to be left with is 1 over x times 7 over 2. Then you multiply this, since you've simplified this, you would end up getting 7 over 2x. And that would be your answer, would be 7 over 2x. Alright, let's see. 4w over v times v to the third over 2w squared. Alright, so we have 4w over v times v to the third over 2w squared. Well, let's start here with the 4 and the 2. Just focus on the coefficients for a minute. 2 is the greatest common factor of 4, so if you divide 2 by 2, you'll get 1. Divide 4 by 2, you get 2. Okay? Now, between w and w squared, w is the greatest common factor, so if you divide 2w by w, you get just 2. Divide w squared by w, you just get w. And then, between v and v to the third, v is your greatest common factor. Divide v by v, you get 1. Divide v to the third by v, you would get v to the second. So what you're going to be left with now is 2 over 1 times the v to the second over w. So if you go ahead and multiply this, you'll get 2v to the second all over w. And that would be your answer, 2v to the second over w. Alright, let's see. We got 6a over 11b to the fourth times 22b all over 3a to the third. Okay. Start with your coefficients first. Between 6 and 3, 3 is the greatest common factor. You divide 3 by 3, you just get 1. Divide 6 by 3, you get 2. So far you're down to 2a. Now let's deal with 11 and 22. Out of those, 11 is the greatest common factor, so you divide 11 by 11, you get 1. Divide 22 by 11, you would actually get 2. So now let's see, you're down to 2a over b to the fourth times 2b over a to the third. It's been reduced to that. Well, the coefficients will factor no further, but the variables certainly will. Between a and a to the third, a is definitely the greatest common factor. So you divide that 2a by a, you're just left with 2. Divide a to the third by a, you would get a to the second. Now, between the b and b to the fourth, b is your greatest common factor. So if you divide 2b by b, you just left with 2. Divide b to the fourth by b, you would get b to the third. So what you are now left with is 2 over b to the third times 2 over a to the second. Let me make sure you can see all that here. Okay, very good. So then you just go ahead and multiply. Since you can't factor any further, you would get 4 over a to the second b to the third. And that would be your answer, would be 4 over a to the second b to the third. Alright. Now, what if we're going to shift a little bit. What if we had something like this? We have a over 6 to the second power. Well, how do we deal with a quotient to the power? Let's say you have, in general, we'll just do x over y, right? You have x over y to the m power. In general, these are two numbers or variables to any given power. What it's going to be is just simply going to be the numerator to that power over the denominator to that power. It'd be x to the m power over y to the m power. So these really aren't that bad. So now you have a over 6 to the second power. Well, a to the first to the second, 1 times 2, that's 2. You would end up getting a to the second over 6 to the second, that would be 36. So the answer you would get for this would be a to the second over 36. Similar one, we have c over 5, that quantity to the third power. Well, in the numerator you have c to the first, raising that to the third power. 1 times 3, that's 3, so you're going to get c to the third in your numerator over 5 to the third in your denominator. That'd be over 125. So the answer you should get for this would be c to the third over 125. These really aren't too bad when you have a quotient to a power. Alright, let's see. You have 2n over 7 to the second power. Well, what you got to do, take the numerator, the whole numerator of 2n, raise that to the second power, over that 7, raise that to the second power. Well, in the numerator, 2 to the second power, that's 4. N to the second power is, well, just that. You get 4n to the second power over 7 to the second power, that's 49. So the answer you should get would be 4n to the second power over 49. Alright, we have 4x over 3, that quantity to the second power. Well, in the numerator, you're going to take that whole 4x, raise that to the second power, over your denominator of 3 to the second power. So, in the numerator, 4 to the second power, that's 16. X to the second power is just that. You would get 16x to the second power in your numerator, over the denominator of 3 to the second power, which would be 9. So the answer you should get is 16x to the second power over 9. Alright, let's see. We have 2a over 5b to the third, that quantity to the second power. Well, start out, take your numerator of 2a, raise that to the second power, over your denominator, the whole quantity of 5b to the third, that to the second power. Well, let's start with your numerator. 2 to the second power, that's 4. A to the second power is just that. So you'd have 4a to the second power over, let's deal with a coefficient of 5 to the second power, that'd be 25. Now b to the third to the second, you multiply, you would end up getting b to the sixth. So the answer you should get for this would be 4a to the second power over 25b to the sixth power. Alright, spice it up a bit. We have a over b to the second power times b over a. Alright, well, let's start out here. Order of operations dictates the exponents come first. So a over b to the second power, that's going to yield to a to the second power over b to the second power. You'll take that times b over a. Well, between a squared and a, there's a common factor of a. If you divide a by a, you get 1. Divide a squared by a, you just get a. Now between b squared and b, there's a common factor of b. Divide b by b, you get 1. Divide b squared by b, you get b. So what you're left with now is a over b times 1 over 1, which is just going to give you a over b. So in the end, you should get a over b. Alright, let's see. We got, let me make this a little bit bigger, eh? Quantity of 3x over y, that quantity to the third power times y to the second over 9. So we got the quantity of 3x over y to the third power times y to the second over 9. Well, let's deal with our exponent here first. In the numerator of this, you'll take that whole quantity of 3x, raise that to the third power, all over y to the third power. Then you'll have that times your y to the second over 9. Now, let's see, 3 to the third power, that's going to be 27. X to the third power is just that. All over y to the third power times your y squared over 9. Well, start with your coefficients. Between 27 and 9, the greatest common factor is 9. So you divide 9 by 9, you get 1. Divide 27 by 9, you should get 3. So what you're left with now is going to be 3x to the third over y to the third times y to the second over 1. Well, the x's don't factor any further. That's okay. The x doesn't. There's no other factor of x. But y to the third and y to the second have a greatest common factor of y to the second. You divide y to the second by y to the second, you'll just get 1. Divide y to the third by y to the second, you get y. So what you should be left with now is 3x to the third over y times 1 over 1, which should just give you an answer of 3x to the third over y. Let me make sure you can see all that, because I did go kind of low. Okay, good. So yes, you should get 3x to the third all over y as your final result. Alright, now let's change it up again. We have c plus 2 all over c to the second times 3c all over c squared minus 4. Alright, so we got c plus 2 all over c to the second times 3c all over c squared minus 4. First thing I would do is go ahead factor c squared minus 4. Okay, so you'll end up having c plus 2 in your numerator over c to the second in your denominator times 3c all over the quantity of c plus 2 times the quantity of c minus 2. Well, it's plain to see you have a common c plus 2 in the numerator and denominator. Those go bye-bye. Now, you have 3c and c squared to deal with. Between the c squared and the c part, there's a common factor of c. You divide 3c by c, you just get 3. Divide c squared by c, well, you just get c. So what you're left with now is 1 over c times 3 over c minus 2. So when you go ahead and multiply this, you would get 3 all over, you can leave it in the denominator as c times the quantity of c minus 2. That is one acceptable answer. You can leave it like that, 3 all over the quantity of c times c minus 2, or you can do the distributive property in the denominator. Since you can't factor any further, you get 3 over c to the second minus 2c. Either answer would be acceptable. 3 all over c times the quantity of c minus 2, or 3 all over c squared minus 2c. Either answer would be perfectly acceptable. Alright, let's see. We got x squared minus 1 all over 16x times 4x squared all over 5x plus 5. Alright, so we got x squared minus 1 all over 16x times 4x squared all over 5x plus 5. First, do yourself a favor here. Factor your x squared minus 1. That would give you the quantity of x plus 1 times the quantity of x minus 1 all over that 16x times you have your 4x squared in the numerator all over, let's factor 5x plus 5. That would turn into 5 times the quantity of x plus 1. Well, it's plain to see between the numerator and denominator we have a common x plus 1 that can go away. So those are gone. Now, between the coefficient of 4 and 16, there is a common factor of 4. So divide 4 by 4, you just get 1. Divide 16 by 4, you get 4. Now, between the variable of x and x squared, there's a common factor of x. Divide x by x, you get 1. Divide x squared by x, you just get x. So what you should be left with is x minus 1 all over 4 times x all over 5. So when you multiply this out, you should get x squared minus x all over 20. And there's no further way to factor this. So you could have left it as x times x minus 1 in your numerator. That would have been fine. I'm just expanding it out since there's no further way to factor the whole thing. You get x squared minus x all over 20 as your end result. let's see, we got a squared minus x squared all over a squared times, we got a all over 3x minus 3a. Alright, so we have a squared minus x squared all over a squared times a all over 3x minus a. Well, let's go ahead and start factoring here. Start with your a squared minus x squared. You would get the quantity of a plus x times the quantity of a minus x all over your a squared times your a. Now let's factor out, let's factor the 3x minus 3a. You could factor out a common 3. You would get 3 times x minus a. Well, let's see here. Between a squared and a, there is a greatest common factor of a. You divide a by a, you just get 1. Divide a squared by a, you get a. Okay, so the closest other factors we have are a minus x and x minus a. If you factor out a negative 1 in the 3 times the quantity of x minus a, you can turn that into a minus x. So what we're going to do here, you're going to have a plus x times the quantity of a minus x all over a times the 1. Now you factor out your negative 1 with the x minus a, you would get negative 3 times a minus x. Well, we can clearly see now that there is a common a minus x. Those will go bye-bye. What you're left with now, we can move the negative sign to the numerator. You would get negative of the quantity of a plus x all over a times 1 all over 3. Now, let's see. That would give you negative of the quantity of a plus x all over 3a. You can leave your answer like that. That's permissible. Or you can distribute that negative. You would get x minus a all over 3a. That's another acceptable answer. Get x minus a all over 3a in the end. Alright, let's see here. We got 10x to the 4th over 6x minus 12 times the quantity of x squared minus x minus 2 all over 4x. Alright, so again, first thing I would say, go ahead and factor what you can factor. You would have 10x to the 4th in your numerator. Now factor 6x minus 12, you would get 6 times the quantity of x minus 2. Okay? Times, let's factor out the x squared minus x minus 2. You would get x minus 2 times x plus 1. So x squared plus x minus 2x, that's minus x minus 2. Okay, perfect. That's the factorization. all over 4x. Alright, well, right away, we notice that the x minus 2's can go away. Those are gone. Now, we have a couple ways to do this with the coefficients. 10 and 6 have common factors of 2, but so do 10 and 4. It doesn't matter which one you pick. I'm going to do 10 and 6 since they're right by each other. 10 and 6 have a common factor of 2. If you divide 10 by 2, you get 5. You divide 6 by 2, you get 3. And yeah, it really factors no further. So what you're going to end up, well, I take that back. You have x to the 4th over the 4x. Well, between x to the 4th and x, there's a common factor of x. You divide 4x by x, you just get 4. Divide x to the 4th by x, you get x to the 3rd. So what you have now is 5x to the 3rd all over 3 times the quantity of x plus 1 over 4. And from what I can see here, this will factor no further. So, a couple of ways you can write the answer. You would get 5x to the 3rd times the quantity of x plus 1 all over 3 times 4, which is 12. You know what, we'll leave it like that. We won't distribute. You can distribute this and you would get 5x to the 4th plus 5x to the 3rd all over 12. You can write it that way, but I'm going to leave it as 5x to the 3rd times x plus 1 all over 12. That would be the answer you would get. Alright, let's do one more here, then we'll call it a night. So let's see, x squared plus 4x minus 21 all over x squared minus 6x minus 16 times the quantity of x squared minus 8x plus 15 all over x squared plus 9x plus 14. Alright, so we got x squared plus 4x minus 21 all over x squared minus 6x minus 16 times x squared minus 8x plus 15 all over x squared plus 9x plus 14. Yeah, that was a mouthful. First thing I would do, factor each of these expressions in the numerator and denominators. So let's start with x squared plus 4x minus 21. You would get x plus 7 times the quantity of x minus 3, and that would be your factorization of that over x squared minus 6x minus 16. Factor that out, you would get x minus 8 times x plus 2 times, now let's factor out x squared minus 8x plus 15. You would get x minus 3 times x minus 5 all over, let's factor out x squared plus 9x plus 14. You would get x plus 2 times x plus 7. Alright, so now we have completely factored everything. Look for what will cancel out. Definitely the x plus 7s. Those will cancel out. We can't go any further with that. And really, it looks like there's nothing else that will factor out. So, all you can do for this is you're going to have x minus 3 all over x minus 8 times the quantity of x plus 2 times the quantity of x minus 3 all over, and times rather, x minus 5 all over x plus 2. So the simplification of this, when you multiply, you would end up getting x minus 3 to the second power, because you have x minus 3 occurring twice, that's to the second power, times x minus 5 all over that x minus 8 times the x plus 2, that would actually be to the second power also, the x plus 2. So the answer you should get would be the quantity of x minus 3 to the second power times the quantity of x minus 5 all over the quantity of x minus 8 times the quantity of x plus 2 to the second power. And that's going to do it for this lesson. Next lesson we will divide algebraic fractions. So I hope everybody has a good night. Take care.